All right, class. Welcome back. This is 4.3, which is the material of solving systems of linear equations using problem solving, which is really just a fancy way of saying story problems. Okay, so story problems. What do we want to do here? Well, first of all, I just kind of want to talk about different types of story problems that you might see. The first type would be direct translation. Direct translation problems would be scenarios. It'd say, oh, Molly went and bought, I don't know, 3 pieces of modern art and 2 pieces of Renaissance art, and it cost her $5 million. And then maybe another scenario that might say, another time she went to auction and she bought, 3 Renaissance and 1 modern art and spent $2,000 or whatever. But I'll give you 2 different scenarios, and then it'll say, assuming that all of the modern art were the same, and assuming that, all of the Renaissance were the same, then what would this be? So direct translation. Another example of direct translation is something that would say, the measure of the largest angle of the triangle is 80 degrees more than the third, stuff like that. Or the sum of 2 numbers is 186. One number is 2 less than 3 times the second number, or something like that, where you're literally just going to directly translate whatever they give you into the scenarios that they give you. So that's direct translation. Okay. Where you could have distance equals rate times time. So I'm just going to call this d times rt. Okay. Where you can tell these problems because they're going to talk about, they're going to say, you went, 558 miles in 3 hours. Or you paddled, 16 miles in 5 hours, or whatever the case is. And whenever they start talking about how far you've gone and the amount of time, you're like, that's distance equals rate times time. Okay, we will also have examples of mixture problems. The nice thing about mixture problems is they literally will say the words mix in them almost always. So for instance, what would a mixture problem sound like? Well, it could say something like, a pharmacist needs 70 liters of a 50% solution, and, all they have is a 40% solution and a 60% solution. How many would they need to mix? Okay. Or it might say, there were, some, 400 and something tickets sold, and out of those 400 and something tickets, 5 of 152, there were some children and there were some adults, but we don't know how many of each. Children's tickets were $5 and adult tickets were $11, how much of each. So might not use the word mix, but it's like pouring into a big cauldron of who knows what, some of this and some of that. Okay, and then we're going to talk about break-even, financial concept that's important in the business world. Break-even just means if something costs you X amount of dollars to make, and then you can sell it for a certain amount of money, then at what point would you be making money? So we will talk more about that. So we've got mixture problems and and break-even problems. Okay, so these are all the different types of problems we're going to talk about. The main key here, when I'm working these problems, what I want to do is I want to first just determine the type of problem. So just kind of wrap my head around it. That might mean reading it and rereading it to understand it. Okay, just because you have to read a story problem 2, 3, 4 times doesn't mean that you are dumb. That means you're normal. Okay, so my first step here is I want to determine the type of problem that I'm working with and just understand the problem. Okay, then I want to identify the things I don't know. So I want to identify and hopefully label them. Labeling is really important so that when you get done with the problem, you aren't confused about which variable represented what. So I'm going to identify and label the things I don't know. So the unknowns. Okay, and then I'm going to plug them in to whatever kind of situation I need to. If I'm going to directly translate, I'm going to come up with two equations that I directly translated. If I'm using distance equals rate times time, I'm going to say, oh, well, there was one trip and there was another trip. Or a mixture problem, I'm going to say there's quantity and there's a value statement or a cost statement. Okay, and same with break even. Again, we'll talk about that. So I want to put them into the situation and solve the system. Okay, I can use substitution or elimination here. Very rarely would you use graphing. Okay, so we're going to solve those using elimination or substitution. Then I just want to check. I want to do a common sense factor and say, hey, does what I found make sense? Okay, so this is kind of the steps, except for this would be to solve using substitution or elimination. Oh my goodness. And this would be check. I don't know how I skipped step 3, but this is where you're going to write your two equations. I said it, but I didn't write it in here. So we'll write our two equations. So we'll figure out what those are. Okay, so these are the methods that I could use here. All right, so this is kind of the process we're going to use. Now, I'm not going to write out these problems, but you need to download the notes from Canvas so that you can have these examples written out and be referring to them. I'm only going to write the important information out of the examples. We're going to go through 6 examples, so hopefully this will be helpful. Students often struggle with this section, but if you can have enough practice, sometimes it'll click and it'll be super easy for you. Okay, so the first example is Katie bought some jewelry on sale. Necklaces cost $15 each. Bracelets cost $8 each. She bought 22 pieces of jewelry for $239. How many of each type did she purchase? Okay, so first thing I want to do is determine the type of problem. This is not a distance equals rate times time. You could consider this a mixture problem. This is definitely not break even. It's not like, well, I bought it for this much and I could sell it for this much, or a business perspective. I could also consider this a direct translation. So let's identify what we don't know. Well, what does the question say? How many of each type did she purchase? So what I don't know is the quantity of necklaces or the quantity of bracelets. Okay, so necklaces, quantity of necklaces, I don't know. So I'm just going to let necklaces be, I don't know, let's represent them with the variable n, and bracelets I'm going to represent with the variable b. Okay, so let's write our two statements here. As far as the quantity statement, I have no idea how many necklaces or how many bracelets were purchased, right? But I do know that total, she bought 22 pieces of jewelry. So she bought some necklaces and some bracelets for a total of 22. This is my quantity statement. Okay, then the other thing I know is that necklaces cost $15 each. So every necklace is going to cost 15. So if I buy one necklace, it's going to cost me 15 bucks. If I buy 2 necklaces, it's going to cost me 30 bucks, and so on. So every necklace costs $15. I can represent that by 15N. Every bracelet costs $8 So I can represent that by 8B. Now, again, I don't know how many necklaces I bought. That's the unknown. And I don't know how many bracelets I bought. But I know that I spent in total $239. So this is going to be, again, I'm going to call this your cost or value statement. In this case, it's a what did it cost you statement. So however many necklaces I bought times the price of the necklace, plus however many bracelets I bought times the price of the bracelets is going to be equal to the total amount that I spent. Okay, now that I have identified and labeled my unknowns here, and I've written two equations, now I can solve these equations using substitution or elimination. Well, in this case, it's going to be easiest to use substitution. So I am going to, first of all, scoot this over just a titch for you. I'm going to use substitution here, and I'm going to solve this equation right here for B. So B is going to be equal to negative n plus 22. I'm going to take this value, because if B is this, I can substitute that into the other equation. So we get 15n plus 8n, or 8b, excuse me, which is negative n plus 22, is equal to 239. So here I'm going to get that 15n, I've got to distribute here, minus my 8n, and distribute here. I don't have a calculator handy, so I'm just going to do this real quick. So we're going to get a plus 176 is going to be equal to a 239. I'm going to combine my ends and subtract the 167 to the other side. Sorry, the 176, good grief. So I'm going to get that 7n is equal to 63. I divide by 7 and we get that n is 9. Now, like I said, by the time you get to this point here, you might forget. You'll literally be like, okay, that's great, n is 9. What the hell does that mean? Well, that means the quantity of necklaces. Remember that n represents the quantity of necklaces, so I know that we bought 9 necklaces. Okay, well, how am I going to figure out then how many bracelets I bought? Well, I'm just going to plug it back into one of my original here, so I'm going to plug it right here into this n, and I'm going to say, well, if I bought 9 necklaces, but I don't know how many bracelets, but I bought a total of 22 pieces of jewelry, when I subtract the 9, then the bracelets are 13. So I bought, or Nancy or whoever, it's Katie, I guess. Katie bought 9 necklaces and 13 bracelets. Now, I'm not going to do this for every problem, but how can I check this problem when we say check it? Well, if I were Katie and I bought 9 necklaces that were at 15 bucks a piece, that would have cost me 135 bucks. If I bought 13 bracelets that were 8 bucks a piece, okay, then I'm going to get $104. Okay, so this is how much I spent on necklaces. This is how much I spent on bracelets. If I add them together, I get $239, which is true. That is how much she spent on the bracelets and the necklaces, so on all the jewelry together. All right, so this is an example, again, of a mixture problem, or you could think of it as direct translation, either way. All right, so the next problem says that the sum of the numbers, of 3 numbers, is 40. The first number is 5 more than the second number. It is also twice the third number. Find the numbers. Well, find the numbers. What numbers are we talking about? So we'll say the first number. Oh, do I know what it is? I have no idea, so I'm going to let it be x. The second number, do I know what it is? No idea, but it's a different number than the first number, so I'm going to let it be y. And the third number, no idea what it is, but it is a different number than both of those, so I'm going to label it z. Okay, so the type of problem here, this is a direct translation. Literally says the sum of three numbers is 40. The sum of the three numbers is 40. That means x plus y plus z is 40. The sum of 1, 2, 3 numbers, so the sum is 40. Okay, so direct translation. Then it says the first number right here, so the first number is 5 more than the second number. That would be y plus 5 or 5 plus y, it doesn't matter. But it's 5 more than the second number. Okay, so another direct translation. The third direct translation problem says it is also, it means or refers to the first number again. It is also twice the third. Twice the third number. Well, the third number is represented by the variable z. So again, we determined this is a direct translation problem. I identified and labeled the three things I didn't know, which were the three numbers. If there's something different, then they have to be represented by a different variable. Okay, then I wrote my two equations. Well, in this case, it was three because we're super ultra cool. So I've got three equations here, and now I'm going to solve this using substitution or elimination. Well, let's see if we can get super genius here. If I can substitute this value for x right here, then this one will be z and so will this one. So I need y to be in terms of z. Is that gonna work? Not so hot, right? It's not gonna work so well. It's not gonna get me the thing. So what if I put everything then in terms of x? Okay, so let's say I want to replace z. So I'm going to divide this equation by 2, and I get that z is equal to 1/2 x. Okay, so instead of having the value z, can I substitute 1/2 x in for z? Well, that would mean that I'd have x here and x here. That's good. Can I get this equation so that I could substitute y and put it in terms of x? Well, if I make y is equal to x minus 5. Okay, well, if that's what y equals, I can take that value, x minus 5, and I can plug it in right here for y. So let's plug that in. So x is just x, y is x minus 5, and z is 1/2 x. And that's all going to be equal to 40. Why the heck did I just do that? Well, I just did that because I don't have enough information here to substitute or to eliminate all these other variables. So if I can get them all in terms of x, then I know how to solve this problem. I can combine my x's. Okay, and so I would get 1x, 2x, 2.5x. Well, 2.5x is really 5/2 x. So we're going to say we have 5/2 x, and then just this minus 5 over here. So again, I've got 1x, 2x, and 1/2. 2.5 x's is 5.5 x, and then this minus 5. And that's going to be equal to 40. I'm going to add 5 to both sides and get the 5/2 x is going to be equal to 45. Quickest way to get to x here is to multiply by my reciprocal. Okay, so I'm going to multiply by 2/5. This will cancel, and I will just have x, and this 5 will go into that 45 9 times. So I get that x is 18. 9 times this 2, x is 18. All right, so the first number then we say is 18. Well, what's the second number? How can I figure out what the second number is? Well, if y is equal to x minus 5 and x is 18, then y is equal to 18 minus 5. So y is equal to 13. Okay, and if x is equal to twice the third, or the way we actually wrote this here was that it was equal to half the third, because we said x divided by 2 is z. This actually should have been 2x is equal to z. It's a problem. Don't worry, I'll fix this in the video, in the problem. Then we get the value for z is going to be equal to 1/2 of x, which is 18. Well, half of 18 is 9. And that means that my z is 9. So how can I check this problem? Well, it says that the sum of all three of these numbers is 40. 8 plus 3 is 11, plus 9 is 20. Carry that 2, and it's 40. That does indeed check out. In the original problem, where it says that x is twice the third, we should have written this 2x is equal to z. But instead I did it half. So instead of redoing this entire problem, rewrite the problem where it says it is also twice the third, write it as it is also half the third. And that would make this all okay. All right, so that was a mistake I made. I'm going to ask you about this mistake tomorrow in class for points. So whoever can identify this mistake in the video will get extra credit. All right, next question. We definitely want to get cruising through these so we're not here all day. All right, next question is going to be, an office supply store sells 7 writing tablets and 4 pens for $6.40. So writing tablets are just pieces of paper. Nowadays we think of them as like tablets, but electronic tablets. It also sells 2 writing tablets and 19 pens for $5.40. Find the price of each. Okay, so let's again say, okay, determine the type of problem. Well, this seems like I could just directly translate it, because it says it sells 7 tablets and 4 pens for $6.40. It also says that it sells 2 tablets plus 19 pens for $5.40. Okay, so this is an example of direct translation. All right, I kind of did this backwards though. We determined that this is direct translation. We're going to identify what we don't know. T means tablets, or the quantity, the number of tablets. And P means the number or quantity of pens. So how many pens? All right, so 7 tablets plus 4 pens, 7 tablets and 4 pens is $6.40. 2 tablets and 19 pens is $5.40. So find the price of each. Well, this problem, the way that it's set up, lends itself to elimination. None of this would be pretty if I tried to start dividing things and solving for P or T or whatever. So we need to make T's opposites. And in order to do that, the smallest number that both 2 and 7 go into is 14. So I'm going to make this top equation be 14. And this bottom equation, I need it to be negative 14, this T right here. So my new equation for the top is going to be 14T plus 8P is equal to 1280. The new equation on the bottom here is going to be a minus 14T, 19 times negative 7. Well, let's just write 7 here. It's going to be 63. It's going to be 133. So that's going to be a negative 133P, and that's going to be equal to, I should have a calculator. $37.80. It's going to be negative. Okay, negative $37.80. So when I add these together, now we are using elimination this time to solve these. Those sum to 0, and I'm going to get a negative 125p is going to be equal to the difference of these two, which is $25. Now, if I want to find this value, I'm going to take and divide, and this is a negative as well, negative 25, because that's negative right here. Divide this by negative 125, and if you take 25 and divide it by 125, that gives you 0.2. So P is going to be equal to 0.2, or in other words, 20 cents. That makes sense. Pens are pretty cheap. I can buy that. Okay, so we've got that pens cost 20 cents. And what about tablets? Well, what do tablets cost? Well, I'm going to back substitute this amount into original equation. I'm going to choose equation 1, 7t plus 4p, which is 20 cents, or 0.2, is going to be equal to $6.40. That's going to give me a 0.8. When I subtract a 0.8, we're going to start over here, 7t is going to be equal to $5.60. When I divide by 7, that means that each writing tablet is 0.8, or 80 cents. Okay, so I've got the P and the T. Over here I said the number of tablets, but it's the price of the tablets and the price of the pens. I know the quantity. The quantity was 7. I didn't know the price. Okay, wow, I should probably stop recording because I'm obviously tired or something, so maybe I should eat dinner. I don't know. Anyway, I'm going to keep plowing through here, finish these problems that we have. So pens cost 20 cents and tablets, writing tablets or notebooks, cost 80 cents a piece. All right, so, and the question said find the price. So the price is the unknown, not the number. Again, apologize for that. All right, the next problem is a mixture problem. You can see as we read the question, it literally uses the word mixture in it. A shop owner mixes M&Ms worth $2 per pound with trail mix worth $1.50 per pound. Find how many pounds of each mixture she should use to get 50 pounds of a party mix worth $1.80 a pound. Okay, so determine the type of problem. It says the word mixture. I know that I'm using it says the word mix, so I know that I'm using the mixture. It's a mixture problem. So I'm going to identify what I don't know. I don't know, the question asks find how many pounds of each mixture. So I don't know the pounds of M&Ms, and I don't know the pounds of trail mix. Okay, well, the variable I'm going to use for M&Ms is M, and the variable I'm going to use for trail mix is T. So, first of all, let's talk about our quantity statement. Do I know how many pounds of M&Ms we're going to put in here? Why, no, I don't. Do I know how many pounds of trail mix I'm going to put in? I certainly don't, but I know that the total pounds I'm going to get is 50 pounds because it says that I'm going to put the mixture together to get 50 pounds of a party mix. Okay, so quantity wise, I'm going to be like, there's some M&Ms, there's some trail mix, and voila, 50 pounds. Great, so that's my quantity. Well, what is my value or cost statement in this case? Again, it's always going to be, I'm going to take my price times my quantity, my price times my quantity, my price times my quantity. So for M&Ms, the price of the M&Ms, $2. So it's going to be 2M. The price of my trail mix is going to be $1.50. So that's going to be 1.5 T. And the price of the mix is going to be $1.80. Well, what is the quantity of that mix? Well, the quantity is right here. It's 50 pounds. Okay. So I know that however much money the M&Ms cost me, plus however much money the trail mix cost me, I need it to be 50 pounds at $1.80. So that will determine how much I put in of each of them. Okay, so for the 1.8 times 50, we're going to get 90 pounds, or 90 here, it's not 90 pounds, it's 90. So we'll get 2m plus 1.5t is equal to 90. So here's equation 1, my quantity statement, and here is equation 2, my value or cost statement. In this case, it's how much the M&Ms and trail mix are costing me. Okay, so what am I doing? Well, we could use elimination or substitution. Just for kicks, I'm going to use substitution. This time I'm going to solve for m. So I'm going to get the m is equal to 50 minus t. And if that's what m is, I can take that and plug it in right here. So we get 50 minus t, 2 times 50 minus t, which is the value of m, plus 1.5t is going to be equal to 90. When I distribute here, I'm going to get 100 minus 2t plus 1.5t is going to be equal to 90. Subtract the 100 and combine these together. I'm going to get a negative 0.5t is going to be equal to a negative 10. And when I take 10 and divide it by a 0.5, the negative 0.5, I am going to get 20. So I get that t is equal to 20. Again, what does this represent? By the time you get to this point, often you forget. So this represents, it's a good thing I labeled it here, and I labeled it correctly this time, that t represents the pounds of trail mix. Sweet. So I know how many pounds of trail mix I'm putting in. I'm putting in 20 pounds of trail mix. Well, then how many pounds of M&Ms am I putting in? Well, if the M&Ms plus the trail mix is going to be equal to 50 pounds, I substituted this for t right here. Subtract the 20 and my M&Ms is going to be 30 pounds. So I'm going to put in 30 pounds of M&Ms and 20 pounds of trail mix for a total of 50 pounds. That checks out. All right. So again, this is a mixture problem. Let's move on to our break-even problem. So this one is a little tricky. Just making sure I'm still recording since I'm probably getting close on memory here. All right, so break-even. Let's talk about break-even, just generally. So typically, costs for a business, you have variable costs and you have fixed costs. Okay, fixed costs are like, I'm gonna have to pay, for my rent of the building, or I have to pay utilities, or whatever the case is. These are costs that I can't change no matter how much I produce of anything. Okay, variable costs are directly associated with the product that I produce. So if I'm gonna produce like bikes, each bike, the material, all of that, the labor for it costs me $50 to make. That will change. This cost is variable. It'll change based on how many bikes I make. But no matter how many bikes I make, I still have to pay rent for the facility that I'm using. Okay, so there's fixed and variable costs. So typically, then we can represent costs with a curve. And for if this is the cost, and this is the number of units, for every unit more that I make, right, my costs are going to go up. But I'm going to start at some level of fixed cost. So say this is like $500, $1,000, $1,500 or whatever. If I make one bike, it's going to be, if I make no bikes, I'm still going to have to pay my $500 of rent or whatever. And then it's going to look like, say like this. So my cost is going to go up for every 10 bikes I make. It's going to cost me more. Okay, so just in general, this is how costs work. Costs increase with each unit that you make. But what about revenues? Well, revenues are simple for these scenarios. Revenues are literally going to be like, well, you know, who cares if the bike cost me $50 to make, but I'm going to go and sell it for $100. Okay, so for every bike I make, I'm going to sell it and get $100. Okay, so here's my cost line. Well, what does revenue look like? Well, for one bike, for 0 bikes, I'm going to make $0. But if I sell 10 bikes, I'm going to make $1,000 because I'm selling them for $100 a piece. So this is my revenue line, okay? And what does this mean? Well, if I make less than 10 bikes, I'm going to lose money because how much I'm going to make is down here, but how much I'm going to owe is up here. Okay, so if I make less than 10 bikes, or however many this is, where these cross, I'm not exactly sure. So let's say it's like 8 bikes. I have no idea. I'm going to lose money. But at this point right here, where these cross, this is where I'm going to break even. This is where my costs are going to be equal to my revenues. Okay, so for break even, we're looking for our costs, which is going to be written in terms of a function. The cost is per unit that we make is going to be equal to my revenues that I make. Okay, so this is how we're going to define break even when costs equal revenues. Okay, so looking at this, a manufacturing company recently purchased $3,000 worth of new equipment to make personalized stationery for customers. The cost of producing a package of stationery is $3. The cost of producing a package of stationery is $3, and it is sold for $5.50. Okay, so that $3,000, that's my fixed cost. I can't change that. No matter what, if I make 0 orders or I make 5 million orders, I'm going to have to pay for that $3,000 of equipment. So, but my variable cost is going to be $3, but that's going to be $3 per thing that I make. So in this case, we're just going to let each order, so X is going to be each order of stationery, which is with an E, by the way, stationery, not an A. Okay, so my cost function then is going to say this, $3 for every order I make plus $3,000. All right, so again, we've got our variable costs plus our fixed costs, and that's going to be equal to our total. So variable costs plus fixed costs equal our total costs, which I represented right here. This X then I would plug in however many, whatever the case is. My revenues though, this said in here that the revenue I get is $5.50 per order that I make. $5.50. Okay, so that just means that for every order of stationery, I'm going to get $5.50. Well, if I want to know the break-even point, all that means is I'm going to set these two functions equal to each other. I'm going to say that 3x plus 3,000 is going to be equal to 5.5x. Then I'm going to solve this by subtracting the 3x. I'm going to get the 3,000 is equal to 2.5x. And if I grab a calculator handy, 3,000 divided by 2.5, that's my profit on each unit, okay? 3,000 divided by 2.5, that means that I need to make 12,000 units, okay, or have this many packages of stationery to break even. So if I sell less than 1,200 packages of stationery, then I will lose money. If I sell more than 1,200, I will make money. If I sell exactly 1,200, I will have made $0. I will break even. My costs and my revenues will equal one another. Okay, so this is the break-even quantity. When it says find the number of packages that must be sold to break even. All right, so that is break even. Okay, last problem here is a distance equals rate times time, because it says an airplane takes 3 hours to travel a distance of 2,160 miles with the wind, and the return trip takes 4 hours against the wind. All right, so find the speed of the plane in still air and the speed of the wind. So what I don't know is the airplane speed, which is also called the airspeed. So I'm going to let that be A, and the wind speed. These are the two things I don't know. But both of these things are part of the rate. These are both facets of how fast I'm going. But if I were to break these down, this information that I was just given, into trip 1 and trip 2. Trip 1, it says that the airplane takes 3 hours to travel a distance of 2,160 miles. So if I do 2,160 miles is equal to a rate that I don't know times the time of 3 hours. If I divide this by 3, I'm going to get 720 is equal to the rate. Okay, because the rate's the thing I don't know in trip 1. What about trip 2? It says the return trip takes 4 hours against the wind. Okay, takes 4 hours, but how far did I go? Well, it's just a return trip, so I went the same distance, but it took me 4 hours. So I'm going to divide by 4 here, and let's see, we get 2160 divided by 4. Now that's going to be 540, I believe. 2160 divided by 4, 540. So I was going 540 miles per hour is the rate. But I don't want to just know my total speed. That's what this is. The total rate is 720 miles on this trip 1 and 540 on this trip 2. Notice that I went the same distance, but one of them took me a lot longer and one of them was shorter. Well, the shorter one is because it said here that I went with the wind, but this one said I went against the wind. Well, if you've ever ridden a bike with the wind, you know that it pushes you and makes you go faster, right? So when you go with the wind, it makes you faster. You can see that this is a faster rate of speed. But when you're going against the wind, it's harder, so it is slower. And you can see here that the rate here is a lot slower. Okay, well, the way that I would set these up is I would say that the rate is equal to 720. So my first equation is going to be however fast the plane was going plus the wind is going to be equal to 720. The second equation is going to represent trip 2. So this is going to be trip 1 equation, trip 2 equation. Trip 2 equation is going to say, well, however fast the airplane goes minus the wind is going to be equal to 540. All right, so this lends itself to elimination here again because these W's are already opposites, so they will eliminate each other. So I'll get a 2A here, and that is going to be equal to 1260. When I divide by 2, I get that the airspeed here is 630. Again, the airspeed is 630, so I know that the plane, the actual speed of the plane is 630 miles an hour. But when the wind is going against me, I'm going to go slower, and when the wind is going with me, I'm going to go faster. Well, how fast is the wind? Well, if I take this airspeed right here and plug it in, so substitute A for 720, then I subtract the 630, then the wind is going to be equal to 90 miles per hour. That is some fierce wind, 90 miles an hour. Okay, so let's see if this makes sense. Well, if I'm going 630 and the wind's going with me, then I'm going 720. If I'm going 630 and the wind is going against me, then I am going 540, and that is exactly the case here. So this is how I would recommend doing the distance equals rate times time problems. All right, well, that was a very long video, but hopefully it is helpful to you. I wanted to spend a lot of time on these story problems because they are very difficult for most students. So good luck. Let me know if you have any questions.